This video goes over how to solve rational equations. So the first thing that we're going to do, if there is any part of the denominator that is unfactored, we are going to factor first. So I'm going to rewrite this as 6 over x minus 4 times x plus 3 plus x plus 2 over x minus 4, x plus 1 over x plus 3. Now I can see that my greatest common factor is actually x minus 4 times x plus 3. So that means that my next step is to make everything into the same denominator. So my second term on the left side is missing an x plus 3 on the bottom. So I'm going to do the same thing to the top. And then my term on the right-hand side is missing an x minus 4 on the bottom. So I'm going to add that to the bottom and the top. Now I'm going to move everything over onto the left-hand side. And then I'm going to expand and collect like terms. So on the right-hand side, I've got 0. My denominator is the same for all three. X minus 4, x plus 3. My denominator also tells me my restrictions on the equation. So I'm going to say that x cannot equal 4 and x cannot equal minus 3 because those are the values that would make my denominator 0. That is where those values come from, which means that if that comes out as a solution to the equation, it's not a valid solution. So my next step is I'm going to expand and simplify. And I'm only considering the numerator because when I have a fraction that is equal to 0, the only thing that I need to consider is that the top part is equal to 0. So my next line is going to look like this. I'm going to expand and simplify. I've got x squared plus 5x plus 6. I'm taking away all those terms from the x plus 1 times x minus 4. And those are all equal to 0. When I simplify and collect like terms, I'm left with 8x plus 16 equals 0. When I solve that, I get x equals minus 2, which is my solution, which is not one of my restrictions. So it is a valid solution. On the second example here, I notice that I now have to factor both denominators. So I'm going to start with that. My first one factors to x minus 4 and x plus 1. And then 3x plus 2 over difference of squares, x minus 1, x plus 1. I notice that I have a common factor. So my common denominator for both is x minus 4, x plus 1, x minus 1. So on the left-hand side, I am missing x minus 1. And on the right-hand side, I'm missing x minus 4. Minus 1, x plus 1, x minus 4. So now I'm going to move everything to one side, working towards collecting like terms. So the other thing that I can do at this step is to state my restrictions, which just come from the zeros of the denominator. Those would be the vertical asymptotes of my related rational function. I'm going to say that x can't equal 1, minus 1, or positive 4, all based on the zeros that come from this factored form of my greatest common denominator. So now I'm going to expand and I'm going to ignore my denominator. So I've got x squared minus 6x plus 5 minus 3x squared minus 10x minus 8, and that's all equal to 0. Now when I collect my like terms, I'm going to get minus 2x squared plus 4x plus 13 equals 0. This is not factorable using my decomposition, tricky trinomial methods. So I'm going to default to the quadratic formula, which is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. I can simplify that to get minus 4 plus or minus root 120 over minus 4. You can simplify using radicals all the way to 2 plus or minus 2 plus or minus root 30. Okay, for our purposes in class, you can stop here. You could use a calculator to get 2 decimals, or you could use radicals and reduce your answer to the 2 plus or minus root 30 over 2. The last example that we're going to do also uses the quadratic formula. I have to find it over here. Okay, this one's got 3 singular fractions. The approach is still the same. We're going to find a common denominator. This time we don't have to factor at all. I can identify my restrictions right away and say that x can't equal 0. My common denominator in this case is 3x squared. So I'm going to multiply everything by what is missing. So I've got 6x over 3x squared. I had to multiply the top and bottom by 3x. I'm going to multiply 5 by x squared because that is what's missing on the bottom. And then I'm going to multiply 7 by 3 because that's how I get a denominator of 3x squared, is by multiplying the top and the bottom by 3. Now I'm going to move everything over to one side, and I'm going to collect like terms. I switched the order of the 2 terms on the left because I know that I'm probably going to have a quadratic equation to solve here. So no expanding. I'm just going to ignore the denominator, and then I'm solving this related quadratic equation, which I also can't factor nicely, so I'm going to use the quadratic formula. I'm going to say x equals negative b plus or minus the square root b squared minus 4ac all over 2a. I can keep going, and I can simplify this down to minus 6 plus or minus root 456 over 10. And at this point, I can either use a calculator to get a decimal, or I can leave it as is, or I can reduce using radicals to get minus 3 plus or minus root 114 over 5 as my final answer.